So I think what I'm gonna have to do, I'm gonna have to take the
Yeah.
get spirit to figure out spherical excess and how they derive it and get their supposed. It's going to take a lot of math. I think Brian's logic's already done this. Figure out where spherical excess comes from in reality. Then they pre-assume that sea level is actually at the curving at the radius that they presume the Earth is. That's the calculation part. So that's not they don't do any measurements there. They calculate what the pre-assumed radius of the Earth is. They add it into the geodetics to start with, and they always say there's spherical excess. The problem is, I think they don't measure. They take the distances from planar, and the distances in a planar survey from point A to point B is actually longer than what they claim the radius is. So they take that extra bit and this is spherical excess. No, that's just the distance between the one point to the next point. And I forget the term they use for how they do it, but they got a geometric term they use in that kind of mathematical equation, which is unnecessary. You can get to one point to the other, and it's the same distance no matter what you do. So what they do with when they actually assume the radius of it, they measure from the core of the Earth to start with, from their assumed core to the edge of the radius. They draw a core line from that point to the other. You know what a chord line is, right?
A core line? You said from
a chord. It's a chord. They draw a chord through the middle of the Earth, from one side to the other. They've actually traveled through the center of the Earth. There's a line that goes through the center of the Earth. It's called a chord line. This is how they get the full circumference of the Earth. They take this assumed radius and they put a chord line through the dead center of the Earth, and they put the two together and calculate the circumference of the Earth, like the full sphere of the Earth. They've never actually measured it. They put that pre-assumption in there. Yeah. That's Ryan. Hey, Ryan. Not much. Trying to figure out what they use chords for, but it's basically the same idea, how to get a circumference of an object.
Or they use it to strike lighter, to make lighter strikers.
Chords?
Chords.
No, not chords. Chords, dude. Chord.
What do you use chords
Chord
for?
lines, yeah.
What for?
To get the circumference of an object, dude.
Okay, but doesn't that object have to be round?
Yeah, usually.
Okay.
The account the 8 inches per mile per square, the parabolic, but they actually use the arc second, and they actually think the stars are actually going down over a curve when they go out of sight instead of perspective. So they just count perspective altogether. Yeah.
An arc second.
Yeah.
An arc minute. There's like, what is it? 30,000 arc seconds in 1 arc minute.
Mm-hmm.
Something crazy like that is you get an arc second. That's a tiny.
Yeah, you can do that with planar surveying if you actually account for a perspective. They use an autographic view when they're mapping like that. That's what what an autographic view is, right?
Oh.
Now I wanted to go through spherical excess. Now let's say, for instance, you put a spherical coordinate system on a flat plane. No, stop. Hear me out before you interrupt me, because I know you're going to do it wrong. Okay. So basically, they're getting greater than 90-degree angles for the calculations. If your grid system gets wider out from its base, like you would on an azimuth, right?
Mm-hmm.
You picture it's getting wider as it goes out. The longitude and latitudes are wider out. You're going to end up with a greater distance, but you're still using the spherical coordinate system. That will give you what you call yourself spherical excess. In other words, it's actually wider as you get to the southern part of the map.
Right.
Yeah. So yeah, that's where they go, oh, we got spherical excess. No, you just got a wider triangle. Yeah.
Why it gets bigger?
Yeah, and the coordinate system you actually have, it tapers off like the globe does. It has to. Well, the only reason they use cosine formulas is because they're actually using spherical geometry to measure distances, and they have to convert it back to what? A linear distance and a planar distance. That's how you get an actual GP. you know what a GP is, right? In celestial navigation, right? You're getting to your next arrival point where the star is that you're looking at. That's your next GP. So you're trying to figure out the distance to that GP.
What does it stand for?
A geographical point, like a not a global. It's a geographical location. They didn't have global, math back when they first started sailing.
Yeah.
That was Magellan and
It's a reference point.
Yeah.
Pretty much.
and the all the atlases are built around that calculation. No, I'm still trying to. They didn't show how they did it. They just said, "Oh, we did it." They're considering the centricity of the Earth. That's where they get the extra from. It's like you go from one place to the other. You 250 miles one direction, 250. You get to one point here, one point there. Do you have to know your longitude and latitude? The way they get the longitude and latitude is the celestials above them. You get an accurate reading if you're out at sea or anything, or even on land in vast locations. You can see the stars from a certain location. That's it. What's that got to do with the Earth? Not a motherfucking thing, dude. They're using arc minutes to calculate where they are, the distance to it. That's just a distance. They're linear. Has nothing to do with geodetics or it's all planar to begin with. Doesn't make any sense, does it? And there's Pontchartrain. Yeah, logical stock that in. Those videos are nonsense, dude. I want to see if there's any more in there right quick. I should have never looked that up. But the thing is, I want to look at their substations and see where they get their coordinates from. They feed it in and their coordinate systems too. They don't even have to actually measure them. They just look them up. And SpaceOut's already shown them to be off in their theodolite measurements of the stars. Their whole system's pretty fucked up.